This video will help you assess income inequality within a country using a Lorenz curve and Gini coefficient. The Lorenz curve was invented by Max O. Lorenz, an American economist, when he was still a grad student at the University of Wisconsin-Madison in 1905. The Lorenz curve is a useful graphical tool for assessing inequalities of any measure within groups, be it firms, countries, or continental regions. It allows us to compare the distribution of income or wealth across groups or over time. The data used for this exercise comes from the UNU-WIDER's Income Inequality Database. To get started, let's move the dataset into a sheet that we can change without disturbing the original dataset. Google Sheets allows you to make a copy of the data, but you could also download the data as a Microsoft Excel file. We do the former in this video. From the menu, select File, then choose Make a Copy. Select where you'd like to save the data and click OK to save. In this video, we will analyze the income inequality in South Africa, so we will name our sheet South Africa's Lorenz curve and select a destination for the file and then click OK to save. Pick a country of your choice. This video uses South Africa. Scroll down to the country of your choice and copy the row and paste the row of decile shares into a new worksheet. Once it's pasted, of course, you have to organize your document. For instance, add a 0, insert another column, rename the row as decile shares, and then move on to the next part. Above this row, add another row with numbers 0 to 100 in steps of 10 and label this row deciles. To create this in 10 steps increment, enter 0 for the first entry, 10 for the next entry, then highlight both cells and drag to the end of the row. The deciles are ordered from poorest to richest, so the decile shares increase as we move from left to right. We see that the poorest people of South Africa receives about 0.3% of national income. The second decile receives 0.75% of national income. The 10th decile, or the richest 10% of people, receive over 59% of national income. To construct a Lorenz curve, we also need to determine cumulative shares, or the share of income received by the poorest decile, the poorest 2 decile, the poorest 3 decile, and so on. To do this, add a row to the bottom of your table with the cumulative share of income in each decile. Label this row cumulative shares. Enter a function which adds the numbers as you move along the table to create these cumulative shares. Enter 0 and 0.38 for the first and second values respectively, and use a function for the remaining values. One way of calculating the cumulative share for the third value is to use a function where D4 equals C4 plus D3, which simply states that the cumulative share of the bottom 2 deciles is the first decile plus the second decile share. Copy the function to the remaining cells in the row by dragging the small blue box at the bottom right of the cell with the function to the end of the series. Note that the cumulative share of income earned by 100% of the population should be 100. If it's not equal to 100, check your function. Now we can see the poorest 20% of income earners in South Africa receive only 1.13% of the national income, while the poorest 70% receive 14.5% of national income. But note that a whole 90% of the population receive only 40.6% of national income, which is way less than half. This implies that the top 10% earn over 59% of national income, which is incredible. Nonetheless, the cumulative shares row will form the curved line in the Lorenz curve diagram. Therefore, the Lorenz curve is a useful visualization of this inequality. In addition to the cumulative shares line, we need a 45 degrees line representing perfect equality, which is what the income distribution would look like if each decile got 10% of national income. To get this, add another row to the bottom of the table with the cumulative shares of income associated with perfect equality. Label the row perfect equality. This will form a straight line in the Lorenz curve. Do this by typing equals B2 in cell B5, then copy the formula into cell C5 through L5 by dragging the small blue box as usual. Draw the Lorenz curve for your chosen country using a line chart. Highlight the data, insert a line chart, and enter the titles for the chart and axes. Once you select that, the chart pops up alongside with the chart editor on the right hand side. To this line chart, we do several manipulations in the chart editor to ensure that the graph is what we need. We make it square and get a grid line for each decile. To do this, go to Customize, scroll down to Grid Lines, and for both vertical and horizontal, you sort of force the major grid line count to have a 10 by 10 square by entering 11. The Lorenz curve shown in the chart gives us a picture of inequality, and it's an easy way to look at the income inequality in a country. It allows people to see visually how concentrated income in the economy is. If a section of the Lorenz curve has a slope greater than 1, that income decile has an income share greater than 10%, indicating that some other decile must have an income share less than 10%. The distance between the Lorenz curve and the line of perfect equality also allows us to see the amount of inequality in a country. The larger the gap, the greater the inequality. Moving on to the Gini coefficient. The Gini coefficient provides a precise measure of the distance between the Lorenz curve and the line of perfect equality. We will calculate the Gini coefficient for South Africa. To do this, we have to come up with a function for finding the areas underneath the perfect equality line and the area under the actual income distribution line. The Gini coefficient is the proportion of the area between the perfect equality line and the cumulative distribution curve A to area under the perfect equality line curve A plus B, with B being the area below the cumulative distribution curve. That is, the Gini coefficient is equal to A divided by A plus B. We do this in a simple and easy to follow way. First, add an additional row B to calculate the area under cumulative share line. Here you will have to recall some simple geometry to work out the area under each line segment. Recall that the area of a trapezoid is equal to the base multiplied by the first height plus the second height divided by 2. Hence, the area under the first line segment is cosine 10 multiplied by B4 plus C4 divided by 2. Once you get that area, you just drag the formula to the end of the series. We can calculate the area of A plus B using the same method we just used before to calculate the area under the line of perfect equality. That is, just copy the formula, confirm that the formula is correct. Once you're satisfied, drag it to the end of the series, and once it gets there, you've copied everything. When we sum up all these triangles, we find that the total area of A plus B equals 5,000. This makes sense, since the large triangle under our perfect equality line has an area of 100 multiplied by 100 divided by 2, which is equal to 5,000. Now that we know the area of B and the area of A plus B, it is pretty easy to calculate the area of A, that is 3485.4. This is the area between the Lorenz curve and the line of perfect equality. Once we get A and A plus B, it's now easy to calculate the Gini coefficient. We simply divide A by A plus B, and we get 0.697 as the value of the Gini coefficient for South Africa. Finally, the interpretation of the results. The Lorenz curve allows us to see how far a distribution departs from the line of perfect equality. The more unequal distributions have a greater area between the Lorenz curve and the 45-degree line, that is the perfect equality line. To be able to do such an interpretation, we need another country to compare with. Let's say we do the same process for the US, then we have two countries to compare and talk about inequality. As before, we just go to the original data set, look for the United States, copy the deciles for the United States, create a new worksheet, paste the data in there, try to organize the data, create space for variable names, and we are lucky that we already have the variable names, so we'll just copy them from the other worksheet that we were working with earlier. Insert a new column and look for the names, copy the variable names and paste them in the new worksheet. Try to organize to make sure everything is as it was in the worksheet we were working with before. Make sure everything is properly aligned, and now we get ready to do the computations. We start with deciles. Once we enter 0 there and 10 because we're trying to create deciles that will be increasing by 10. So we just copy that to the end of the series, move on to cumulative shares. The first two cells are just copied as they are. Then we enter a formula there. So we enter C4 plus D3 and copy the formula, drag it to the end, move on to perfect equality. We just copy the deciles figures as they are and drag the formula to the end. Once we have that, then we select all the data, click insert, select chart, and we have our Lorenz curve, but then it's got variables that we're not interested in, so we just organize, add the axis. The deciles should be on the x-axis, remove the deciles from the y-axis, and also remove the decile shares. Then you're going to remain with the Lorenz curve as it's seen there. The next thing to do is simply just renaming the x-axis, renaming the chart itself, and renaming the y-axis. Basically, this is the Lorenz curve for the United States. Moving on, we would love our curve to be a square. So what we're simply going to do is go to customize, then under grid lines, change the major grid line count to 11. Just enter 11 there and press enter. Then do the same for the horizontal axis. And there we have it. That's our graph. That's the Lorenz curve. Next, we need to calculate the Gini coefficient. And so we create a row of B by entering a formula in C7 equal to 10 multiplied by B4 plus C4 divided by 2. Once we get our B value at the 10th decile, we need to copy the formula to the end of the B row by simply dragging the formula. Once that is done, we calculate for A plus B using the same formula. So we simply copy from C7 and then drag the formula all the way to L8. Our interest is in the totals, so then we get the sum of B's and the sum of A plus B's. Once we have A plus B, it's easy to calculate A, which is simply A plus B minus B. And finally, we calculate the Gini coefficient for the United States. So as usual, the Gini coefficient is equal to A divided by A plus B. So we simply just divide those values and get our Gini coefficient at 0.4 for the US. The calculated Gini coefficients can also be reflected in figure 5.16 of the economy textbook. Clearly, with a Gini coefficient of 0.4 for the US and Gini coefficient of 0.69 for South Africa, then there is more inequality in South Africa than the USA. This is also visible in these graphs for the two countries seen here. The gap between the perfect equality curve and the cumulative line is bigger in the case of South Africa than the USA. A candidate for explaining this observation can probably be unearthed if considerations for disposable income inequality were made.